Okay, the second topics that we will study is about carbocation stabilization. I hope you still remember about what is carbocation. It is carbon that has positive charge, yeah, since it produced from the heterolytic fission in halogenoalkene, yeah. So this will produce CH3 positive. This is methyl carbocation, NCl negative. Now we want to learn about factors that will affect the stabilization of this carbocation. Okay, before we learn about the factors affect the stabilization, let's learn about the types of carbocation. There are three types of carbocation. The first is primary, the second is secondary, and the third is tertiary carbocation. The differences about them, yeah, is about how many R group connected to the C positive. Once again, the C positive, how many R that attach directly to the C positive. In primary carbocation, the C positive only connected to one R group, one C only. The secondary connected to two R groups. In tertiary, there are three R groups. Okay, understand? You can see also through this diagram, each R group shown by covalent bond with arrow. Look here, covalent bond and then with arrow. What that means? Okay, later I will tell you what this is about. Okay, you can see the orange statement here. Alkyl group. Our group is alkyl group. Alkyl group has the effect of spreading out the charge on the carbocation. The more alkyl groups adjacent to the positively charged carbon atom, the more stable the carbocation. So, our group is an electron donating group. That means this group will tend to push electron to the adjacent atom. Yeah. So in this case, because R bonded to carbon, so it will tend to push electron to the C positive. Once again, C positive, that means this C deficient in electron, right? C positive, that means deficient in electron. So how do you think if there is an atom that will tend to push electrons towards it? This carbon will become more stable, right? Okay, so you can see that if you have many R groups, for example, in tertiary carbocation, there are many groups. That means that spread out the positively charged ion, yeah, the positive charge in carbon. There are three groups that help to spread out the charge. Okay, so that's why tertiary carbocation is more stable. The secondary only have two R groups that help to spread out the charge, and the primary is the least stable since only has one R group. Okay, understand, yeah? This phenomenon we call as inductive effect. Okay, more R group, more inductive effect, more stable. Yeah, positive inductive effect. Okay, so look at this question. Which of these carbocation is most likely to form as an intermediate in an organic reaction? Your knowledge about carbocation is very important, yeah, since in chapter 15 until 18, we will learn about organic reactions mechanism, and most of them goes through the carbocation intermediate. So if you can understand about this well, you can understand about the mechanism well. Okay, so which one? To form as an intermediate? Okay, A is secondary, yeah, because two R groups. B tertiary, while C is primary. So the answer is B, because it is a tertiary carbocation, yeah. More R groups that help to stabilize the positive charge. Next question, there are 4 different carbocations with the same formula C4H9 positive. One structure is given in the table. Suggest the structural formula of the 3 other carbocations. Okay, let's discuss about this. This is same like when you should make the isomer. Okay, so first we will see that we can change the position of the positively charge. And in structure 1, positive charge at the first carbon. So let's move to the second carbon. Okay, of course you should complete with hydrogen, yeah, but I will make this simple. Just show the C1. Okay, how about structure 3? Can I move to the third C like this? No, yeah, because this will make this is same as the structure 2. So not like this. So there is no other possibility to move the positive ion, the positive charge, I mean. So now let's make the branch carbon-carbon chain. Now we can put the positive charge at the first carbon here. Okay, and to the second carbon. Ta-da! Done. Okay, there are 4 possibility. There are 4 structure for the carbocations with the formula C4H9 positive. Okay, if I ask you, which structure is the most stable? Structure 4, since it is a tertiary. How about structure 3? Is this primary, secondary, or tertiary? Structure 3 is primary. Yeah, only connect to one C. Yeah, although this is propyl, but connected to this C only, yeah, CC. Yeah, only one C. And this is secondary, since 2 R group. And this is primary as well. Okay. Okay, so far we already learned about homolytic and heterolytic fission, also the stabilization of carbocation. So please remember that the more R group around the C positive, yeah, the positive C, yeah, the more stable the carbocation because of positive inductive effect. Once again, R group is an electron donating group, tend to push electrons to the adjacent atom.